Alright, just let me check the audio if the audio is coming. Alright, just let me check the audio if the audio is coming. Audio is coming. Okay, we're going to mute this and let's get back to our. Alright. So we built a linear regression model. The next thing we were going to do was create a classification model. We can use TensorFlow. Okay, let's see. Let's put in. Creating an image classification model. After image classification model, we're going to do language model. So I'm excited about that. Images from scratch. Let's see. PyTorch components. Okay. Dog and cat is interesting. What was that? Image net only. Pillow to read an image of the command. Image level using variety of non-network components provided by PyTorch. Okay. Imaging that feature not mechanism. I will read this again. I think like what this guy is trying to do is set up some basic understanding of how the model will work, which I think is important before we get started. There are a lot of different terms out there that have the same or similar meaning in regards to computer vision. Take for example image classification, detection and segmentation, but also think of object detection, recognition and classification. These terms are a lot commonly interchanged, so the meaning of these terms are dependent on who you are. Python to train it as simply PyTorch vision to transform the data. Think of transformation as the following. We will be reducing the image resolution, transform the image and label two tensors and make sure that each image has 3 channels. If they are scale, okay. Data loaded to load the image data set into model training ready for match, which makes the model training program. Okay, think of neural network building blocks. Okay, these building blocks will be used to build the skeleton of the computer vision network. Besides these, PyTorch. Okay, building block explained. So now let's focus on this. I think this will be very useful and important. Convolutional layers are the layers that generate feature maps that contain. Okay. In the image, I will now explain what components will do for a network. Convolutional layer, 2D convolution layer. Generate feature map that contains information about the features in an image or previous feature maps. Does this through the concept of matrix algebra and a convolution kernel filter. An x by x kernel strides over the image with x strides in 2 dimensional. The matrix has predetermined values that gets multiplied with the matrix the kernel is focused. This is to sum up all the values in the resulting matrix to get one single value in the feature map, as shown in figure 1. So 2 by 2 come stride 1, kernel receptive field 0 0 0 1 equals to 0 0 0 0 1, stride 2. Okay, so you're moving right wise and then row wise. So first, second. Okay, so first we get this, second we get 1 2. Okay, so basically in a grayscale image we are trying to calculate how much squares are colored in a way. So for the first grid it is 1, for the second it is 2, for the third it is 2, and for the last it is 1. And then we go below this 0, right, then 0, then we'll have 2, right? Much kind of a grayscale image, but also use multi-dimension for RGB. After any correlation, we need to add an activation function. Within my model, using the ReLU activation function. The options are leaky ReLU, is used to acquire an output from a correlation feature map. In the neural network domain, the most common activation functions are non-linear functions, such as these types of and realize the input rate on the other. Okay, let us understand. We are now working on image classification model. Explain 2D conversion model. No, what was that? And activation formula. Activation function, sorry, not formula. So let's close a lot of unnecessary pages we have opened. Stacking layers is used because model stays linear. Activation adds non-linearity so we can learn complex particulars. Stands for rectified linear. Okay. ठीक है, we'll keep moving forward. 2D maximum pool layers. Pooling layers are typically used to stack convolution layers. This is to reduce the size of feature mass generated by the convolution while maintaining its depth. So we start with the convolution layer, then we do an activation function, then we do maximum pooling layer, and after which this data goes to convolution. One vector linearly. Let's go to the next one. Isn't there like even more simple example of image classification? So I think these are the common things that needs to uh, convolutional neural networking. Next, image classification model. In that we learned that we use CNN for CNN is convoluted neural, which has many layers. Include including okay, so just many layers including convolution layers, evaluation layers. Convolution layers हो गया. Then ReLU activation, pool maxing, flattening, and एक और रहता है fully connected layers. So to max output. Okay, so we'll create a new folder. Let's just add get status. Simple image classification. .py. Okay, for this we also need to install pip install TensorFlow और कुछ TensorFlow से हो जाएगा. We'll start importing TensorFlow as TensorFlow. From TensorFlow, here import dataset layers models. Now we load the CFAR 10 data set and process it. It consists of 60,000 32 by 32 color images across 10 categories. We scale the image pixel values from 0. So since the RGB values range from 0 to 255, we're going to divide the value divided by 255 We'll get the values from 0 to 1. One hot encode converts the label 0 label. X train, Y train, X test, Y test. Data set CFA 10 load data. Okay. CFA 10. So let us see what we're actually using. Okay. Okay, this is our data set. Okay, let us at least, or simply for train, let's print out x underscore test shape. Now let's just print out. So we're waiting for the dataset to be downloaded. Shouldn't be that long. Okay, what we are doing next? So after we get the training data, next thing we are doing is scaling. X train, Y train, Y train. Well, it's hard to see the structure, but I think for each image we are getting array of values, and each cell of the matrix defines the, oh no, I think they combine to give the RGB value of Okay, so let me just do the zeroth index. Let's see what happens. I think before we start working, we should definitely understand. So, will it like download every time? Let's see. No. Okay, thank God. Hmm. A tuple of two tuples of numpy arrays is contained in the training end. Okay, I think like each category has been given. Okay. The labels. Okay. Basically, what I want to say is that for each image, uh, first of all, we are getting like 10,000 images, and then for each image, we are getting 32 by 32 pixels. So that, let's say 3900 like elements, each element having an RGB value. So a lot of data. Um, yeah, it is a lot of data. So to see, I want to see this data, right? Got it. I think so. What happens is now, like for example, if I print y test and I'll print the zeroth index value. So initially it was like an integer, but now what we'll see is an array representing the value. So let's print it out and see. So 0, 1, 2, 3. The value is 3. So what we are doing here is basically converting which means गलत है ये I think it should be long. I think the next time I read it, at least I should be able to understand the code. So that's what we are doing. So once we get that, what the next step is to create the model. Building the CNN. Now we define the CNN architecture and start with the convolution layers, following by max pooling layers. Flatten the output, and then feed it into fully connected layers. Convert the 2D matrix into a 1D vector for the dense layers. Fully connected layers used for decision making. Using softmax activation to predict probabilities. Max point. Trains neural network model using Keras or TensorFlow and stores the training history. Stores the training history. Input features used for training true wide range equals labels. And epoch means one full process of the entire training set. Batch size. Training data is getting. So if I want to check for an image, what I'll have to do is make it 32 by 32. For each pixel of the image, I'll have to calculate the RGB value and create a vector and pass it to my model. Only 42%. Right. Each epoch. This is a sample batch of size of 1 epoch days. Any major forward pass last year. So our accuracy is increasing and our run accuracy is also increasing. So our model is getting better and better. Convolution internal specialization. Yeah, I want to instant value activation here. Rectified linear unit is a popular activation function used in non-active, especially in defining what it has become the default choice menu activity to this. This is a piecewise linear function that outputs the input directly if it is positive, otherwise it outputs zeros. Basically turns any negative values into zero. Okay, let us learn more about TensorFlow. You YOLO, you only look once. We are almost done.
Hey everyone, my name is Rob, and today we're going to be using Python to do some object detection using YOLO v5. If you've never heard of YOLO before, it stands for You Only Look Once, and it's an open source package for doing object detection. It comes with pre-trained models, so it can do some object detection just out of the box. You can also fine-tune it on your own data set if you want to do custom object detection. I first came across YOLO v5 when working on some Kaggle competitions with object detection, and it really currently is the state of the art. There is a lot built into it that makes object detection just easy to do, so we're going to walk through that and see how it goes today. Okay, so here I am on the YOLO v5 GitHub repository. You can see that it's a pretty active repository, and they do have description here of what it is and have some official documentation. To get started with it, the first thing we actually need to do is clone this repo. Now I'm working on my desktop machine, which is a Linux machine running Ubuntu 2004, and I also have 2 GPUs in this machine that the YOLO v5 will use to predict. It also uses PyTorch as the backend where all the models were trained, and we will actually set up a new environment here that will run YOLO v5 and have all the correct packages installed. So I'm switching over here to my handy terminal, and I'm in my directory where I like to clone my repositories, and all I'm going to do is run this git clone here. Now it's recommended too that you have Anaconda installed. Right now I have Anaconda installed on this machine, and that'll let me create a brand new Conda environment for YOLO v5. So what it says to do next is just a cd into this directory where I cloned, and if I do lctr, we can see these are all the files from this GitHub repository that we have cloned. And then I'm actually going to Conda create with the name YOLO v5. So I'm going to create a fresh new Conda environment where we can install all the required packages. So I just do that by doing conda create -name. I named it YOLO v5, and I do need 2 dashes here in the name. And I'll type yes to install all these dependencies. Okay, so in order to activate this Conda environment, I just do conda activate YOLO v5, activate it in this environment, and you can see because it says YOLO v5. I also made sure I installed Python 3.8 because the docs for YOLO v5 do say it needs at least 3.7, it looks like. So now that I'm in here, I can just pip install all the requirements that are in this requirements text. If you want to just look in the requirements text, these are all the packages that it will install, and it will make sure I install all the right versions. So this might take a little while because it's going to have to download some of the wheels if it's your first time installing these packages, and it needs to run through and install them all. Okay, so it looks like it's done installing them all, so I'll just clear this screen. If we look over in the repo in this detect.py, we can see that it actually can be called just from Python with some arguments. So by default, it will pick certain weights to use. So YOLO v5 comes in different sizes. Let's look and see what sizes of the weights that we have as options. Yeah, so they're shown here. YOLO v5, the smallest is N, and the largest is X, and it looks like there's even a new one, efficient jet version of it. And what else are we going to get? We're going to need to provide it the source. Now I want to provide it my webcam to see if it will run directly on my webcam, and we just provide the number where the webcam is associated. So if you only have one webcam, you'll be putting in 0 here, and we'll see how that works. And we're not actually providing any data to train on, so we don't have to worry about this. That's all we really need, I think. Okay, so I think I have it working here. The command that I needed to run was just Python detect, and then I'm using source 5, which is my second webcam, and I have a green screen here behind me, so it's going to show the green screen when it loads up. Let's try running this detect and see how it works. We can see that it is using the small version of YOLO weights, but there we are. So you can see me, there's a person. Here's my, it thinks my fingers are carrots. Thumbs up. Let's hold up, let's take off my glasses. No glasses. Tennis racket. All right, not perfect, not perfect. Phone, cell phone, it's good at that. Maybe a cup. Okay, yeah, that's pretty good. And you can see the confidences are shown on the side of the image. So it's drawing the bounding box and showing the side. But if you wanted to pull out just the bounding boxes, you could do that as well. Or store any information from YOLO v5 by going into the source code. Cool, so we're going to kill that, and let's try to load the larger weights, because the larger weights are going to mean that it performs more accurate, and it might be a little bit slower, but it's going to perform better. So what we need to do to get the larger weights is run Python detect and then feed in the YOLO v5 X weights and then give it the same source. Now you can see it's actually downloading these weights, fusing the layers. All right, a little bit slower to do that as maybe. All right, so then I'm using source 5, which is my second webcam, and I have a green screen here behind me, so it's going to show the green screen when it loads up. Let's try on the side, load the larger weights, because the larger weights are going to mean that it performs more accurate, and it might be a little bit slower, but it's going to perform better. So what we need to do to get the larger weights is run Python detect and then feed in the YOLO v5 X weights and then give it the same source. Now you can see it's actually downloading these weights, fusing the layers. All right, and now we're back to my object detection. You can see the chair. It sees the corner of the chair. It knows this is a lot better. Does it think my fingers are still? No, it's pretty good about my fingers. Maybe if I just hold my hand, no, it thinks I'm a person. Cell phone. This is just working on the default pre-trained weights, but if you wanted to, does it know this is a microphone? But you can make it more customizable by fine-tuning the training on a different data set that's pre-labeled. There we go. Look, that's pretty good. It's pretty confident of all the things. Now let's try to run it on video data set. So I do have this data set, which is a video footage of a bunch of different cars driving around, and I'm using this for a different YouTube video that I created on working with video data. But let's try to run this object detection on this video and see how it works. We're gonna call this again, but instead of giving it a source, we're gonna give it the desktop MP4 file. Okay, so it looks like it's running, and it's detecting people, bicycles, cars. So what it's doing here is it's running now on this data set. It has the number of frames that it's gone through of the entire video, and the number of people that it sees, cars. These are just some of the labels coming out here, printed to our command line. So it looks like we can provide it view image like this in order to actually view the images as it's processing. Yeah, there we go. It's a little bit slower, but it is working. We see that it's detecting all these different cars and objects, even detecting the traffic light, which is really impressive. So if I kill this now, I can change other settings like the confidence threshold and the IOU threshold. So if we only want it to show objects that it's very confident of, it's defaulted to 0.25, but let's change that confidence threshold to 0.9 and run that. There, now it's detecting much less because the threshold that it needs to detect in order to show needs to be at least 0.9. Let's do 0.5. Okay, that looks pretty good. And then there's also something called an IOU threshold, and this basically means it will
Okay, so basically our accuracy and val accuracy, we're able to reach 0.86, which is pretty good. Waiting for one more. I think it should be 87. Yep. And now we should see the output graph. I think, yeah, here it is. So the graph is accuracy and val accuracy, training, and so with each epoch our training accuracy increased very evidently, and the test one grew, but it became static data. So if you could see, 0.5 we started, then 0.71 only it was able to maintain. Okay, great. Test accuracy 0.7. So the average is, if like we're talking from 0 to 1, the average is 70. So 70% of it was able to accurately predict. Now the more data you have, the better it will be, and the more number of epochs you run, the more the accuracy will increase.
Press any objects that it detects that overlap each other. So IOU has to do with the overlapping of two detected objects. 2.9 for the IOU threshold. It's 0.5. So what's happening here is when we set the IOU confidence to be really low, it won't allow any boxes to be overlapping each other very much. It'll just suppress any object detection that overlaps with another object detection. So by turning this off and setting it really high will allow for a lot of overlapping boxes. And let's do one last run with a really low confidence threshold and a high IOU threshold. There we go. So this is a lot of different boxes, and even this car that it's detecting in the lower right side is very low confidence, but it's displaying it because we set that confidence threshold so low. Thanks for watching this video. It's a short introduction to using YOLO v5.
Okay, let's do YOLO V5. Okay, let me stop. I'll stop streaming. I'll set it up and then I'll join